Hello and welcome. In today's video, we're going to be talking about UTNuPro because we have turned it into a Python package. As you know, UTNuPro is a software that we've had for a number of years, so roughly 10, that allows you to calculate nuclear properties for a given material mix. So the inputs that it's going to take are going to be the material that is used. And that's described by the formula, the chemical formula that constitutes that material, the fraction that can be given as a fraction volume or a fraction mass, and the density, either of the component or of the whole mix. There's ways to decide which one you want to use. Also, it has some special or extra options. You can decide, instead of giving a specific material, if you have a solution, instead of formula, fraction, and density, you will just give it the salinity that brine has, the temperature and the pressure, and it will calculate the density internally. You can also give it a temperature if your material is sensitive to that, and you can also give it the neutron source. But it can be americium, beryllium, californium 252, or you can just give it a number between 1 to times 10 to the minus 11 to 20 MeVs, and this just means that the source is monoenergetic. And once you give it those inputs, you're going to get as outputs all the nuclear properties that are calculated, which include the slowdown length, sigma, the thermal absorption cross-section, density, electron density, and so on. The ones that you probably are familiar with, bulk density, and so on. To get this software, you need to be part of the Formation Evaluation Consortium and send me an email. I will send you a link, and from that link, you can download these files. These 4 files are going to be there. The wheel, it's the Python wheel. Some of you guys are probably familiar with that, with what that means. But those that are a little unsure, just ask your IT or look it up. It's very straightforward. And very importantly, there is this install.txt, which I have open up here, and it just shows you how to do the installation. Here in my left, I just have a PowerShell which is in this exact same folder, UTNuPro Python, and I have it in a specific virtual environment. That's what this folder is, and this is why you have this VNV here. I trust most of you that are using Python are going to be familiar with these concepts. Otherwise, feel free to reach out or again ask your IT or your trusted Python expert. These are relatively basic concepts. Now, once you are here, you can install it just by using this, just typing this. Make sure this is just the wheel. Just pip install and then the name of the file. And then it's going to take a few seconds. It was pretty fast. That's good. Now that it's installed, I can use it, or I can try to use it. And the first time that I tried to use it, I'm going to fail. So I'm just opening Python, and this is just interactively. I'm going to try to import UTNuPro as UT. So I just type import UTNuPro as UT, enter, and it's going to fail. The reason why it's failing is because you require a license, and it's telling you that there is no license file here. And this is where it's expecting it. This is in my case. In your case, it might be different because I'm using a virtual environment. It's within venv, then library or lib, side packages. And you see that when we installed the wheel, it generated a number of folders, UTNuPro license, and the distribution information. And you need to copy your license. It's exactly the same license that you use for the standard formation evaluation UTAB wells. And in my case, I'm just gonna get it real quick. This is my license, so I just copy it. You can copy it from wherever you have it and just paste it here inside that UTNuPro _ license folder. These two files, well, this file and this folder are irrelevant. You can delete them if you want to, but they need to be there just to make things easier. They need to be there when the folder is made. After that they can be removed. Anyway, so once you have that license there, I can try to import UTNuPro as UT inside Python over here. And now it didn't crash because the license was found. It's setting everything up, and now it's done. Now, the way you use it is described here. There's more information, there's more clarifications on how all the options that you can have, but I'm just gonna run a couple of simple examples. So for example, if I want to calculate, I'm just gonna say, calculate for water. You give it, for any material, you just give it the fraction, the density, and the name of the chemical formula of the material. Then you give it the source, in this case, AMBE, and then just enter, and it's done. It's calculated. And if I just print the result, I see that I get a dictionary with all the properties that I mentioned before. You have sigma, the migration length, hydrogen index, and so on. And you can do it for any number of materials. I'm going to do it, for example, not just for water, but if I want to do it for a mix where I have some quartz and some water, so it's 80% quartz. This is the density that I am assuming quartz has, and then 0.2 water, and that's it. And I can see the results, and I see all of them right there. And if I want to see them in a better format, I have another. I'm just copy pasting these lines. And you can say, okay, if I just print the hydrogen index, this is what I have. Slow down length, thermal, and sigma down here. So it's fairly straightforward. It's pretty quick, and it's great for doing it not just in one case, but for doing it in multiple cases. I'm just gonna quit Python. And as you probably know, in Python, you can run a script. So I'm gonna go here to where I was, and these two other, so we've seen the wheel, we've seen the install, and we have these other two. So here in the water test, I want to see what this contains. It's just an example of running the reference for water. And then instead of using H2O, I'm giving it water using the salt, meaning it's brine with 0%, zero fraction of salinity, then a temperature and the pressure. And then I want to see the result for each one of those. And to run it, of course, I just do Python, and then I just say water test, and run it. And then right away I get the results. Very quickly, I get all those. So you can see how this simple script can be very, very powerful, because you can modify things systematically and make them comparisons, make plots, do sensitivity tests, and so on. And we have one that is a little more interesting, this sigma water. What we have in this example is, imagine that you have 80% quartz and 20% water, and then you want to see, not water, 80% porosity, sorry, 80% quartz, 20% porosity, and you want to know how does sigma respond to the different water saturations. This is what I'm doing here. You can see it with more detail in the when you download it. But here I'm just going to run it. And what I'm doing is I'm running all those tests that I told you, and then I am making a plot that shows the results in a pretty way. So now you can see that the value of sigma for the different water saturations, and you have a little more of what it looks like. Everything was done with 20% porosity and so on. So it's very easy to use. We could have made it more detailed. We could have varied anything. We could have varied the temperature, the salinity. We could have had more components. You can test different types of shales. The options are unlimited, literally. So I hope you guys find it useful, and let me know what you think of it. If you have any comments, let me know. Send me an email, and I hope to hear back from you guys. Thank you.